Okay, so we talked about this, and I realized I don't have a recording for this particular unit exam. So I guess we'll give it a shot here and put that together. So yeah, so a little bit about Ramon sums. Hopefully not the hardest topic that we have, but clearly if we have this region right here that spans a total of 3 units, we are looking for a representation of the answer of the integral from 1 to 4 of 2x squared minus 3x plus 7 dx. Keep in mind, we're going to be doing that using a right side Ramon sum as opposed to finding the definite integral with which would be more precise. But if we have something that is exactly 3 units wide being broken with 6 partitions, then I know that the value of every single one of those things would be half. Now, again, technically what we're doing is b minus a, which is 4 minus 1 divided by 6, or in other words, b minus a over n in general. Now, that's assuming that we're having even subintervals, which is what we tend to do if we have an equation. And you want to remember that if we're starting at 1, and proceeding all the way to 4 with those 6 subintervals. And we wanted to have that thing hit with all of those partitions hitting on the right side because that's what it says. The way we like to do those things is we like to have them then hit at their right side, which ultimately means the first partition doesn't hit at that left edge, it hits at that right edge. So since I'm starting at 1 and going to 4 with partitions of width 1/2, then the first partition is going to happen at f of 3/2. And then, of course, moving over 1/2, we're at f of 2, and then f of 5/2, then f of 3, etc., right? And we are going to proceed until we reach f of 4. So not much of a dot, dot, dot on that one because I really only, I guess, skipped one value. Now, as far as doing that within a calculator, we could pretty quickly plug in 3/2 and go get that. But it turns out I did that off to the side, so I'm not going to take the time on a video to have you watch me hit buttons on a calculator. But I went in and I evaluated each of those numbers by plugging 3/2 into the original equation, by plugging 2 into the original equation, and then 5/2, etc. And I found that that area was 46, which again, the question is, sometimes we would ask, is that an overestimate or an underestimate? But we really need to look at the curve specifically and think about the concavity and the curvature to know that. Now, this one right here, 1 over x squared is a little bit of a different curve than what we're often used to looking at. It's one that actually has an asymptote going right down the middle of it. It comes like this, and it's actually asymptotic to both the y-axis and the x-axis, actually quite rapidly on both cases. But we're looking at for what happens from over here from specifically 1 to 3. And so even though this is a discontinuous function, the region that we're looking at is perfectly fine. Now keep in mind I'm going from 1 to 3. So the interval width is 2 units broken into 5 subparts. So each subpart being exactly 2/5 of a unit wide. So I would start with 2/5 as my interval width, and then the heights, because base times height, that would be f of 1, and then, which is of course 5/5, right? And if we move over from 5/5, we would land at 7, and then 9. Some of these problems that are limited in partition width, it almost doesn't make sense to do a dot, 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 because there's just not that much information there. And so if we were to do that, I have 2/5, again, plugging in the number f of 1, you would get 1. And then 7/5 squared would be 49/25, but of course it's upside down. So this is 25 over 49. 9/5 squared would be 81 over 25. And so kind of going down the line through each of these numbers because they are each being squared and then flipped over, fairly simple values. And when I put that all together, it turns out the denominators to make a common denominator and answer it legitimately are far from pleasant. And so I'm just going to say that's approximately 0.869. Hopefully not particularly difficult. The test, of course, could have a midpoint Ramon sum. and it could have a trapezoid rule. So just be aware that we've done all of those things and we've looked at them fairly extensively. So kind of keep that in mind. Number 3 has to do with the idea that we're first going to factor that 5 out to the front, because that's really a skill that you want to think of. The second piece of that problem that I think is significant is just memorizing and understanding what something really looks like. This right here is the equation of a semicircle that started at -7 and went to +7. So we should be pretty aware that the area of a circle is pi r squared. We are not going to do full-blown calculus on this problem. We are going to use our basic geometry. So if we had pi r squared, that would be the area of the entire circle, but we're only looking for half of that circle. And of course, don't forget that 5 that was sitting in front is still a player in the story. And so when I did that, 49 times 5 is 245. So I ended up with 245 pi over 2 as the precise value of that thing. And I'm not using a calculator because I don't need one. Now, number 4, this is what held me up a little bit. There's actually a weird little flaw in this question that I really didn't think about when I wrote it. Part of the principle behind this question is that if you took the cube root of x cubed, you get x. And by the way, that is a 100% true statement. The cube root of x cubed is x. But here's the problem that a lot of people do, is they will say the square root of x squared is x. And therefore, we're looking at this thing and we're believing that this is 2x divided by x, which is 2. And you might be like, oh, but isn't there a hole at 0? But it's a removable discontinuity, so it's infinitely small. So we're looking at an integral from -1 to 3 of the number 2. Oh, how simple. A height of 2, here's y equals 2. Going from -1 to 3, what a joke. I mean, literally, what a joke. So I'm ignoring the 4.8 for a second because I'll put that back in here in a second. But I would go from -1 to 3, or a base of 4 by a height of 2. This thing is going to have an area of 8 times 4.8. And we have this super easy number, 38.4. The problem is there is a sneaky little thing that is happening in this question that, honestly, I just didn't notice. And when I first, looked through it, the problem is there is a fallacy right here. This is wrong. And it's a subtlety, very, very subtle thing. Your 4.8 integrals from -1 to 3 of the cube root of x, which is x, plus the square root of x squared, which is actually the absolute value of x over x. Now, here's the problem. If x is a positive number, then x plus x is 2x, just like what we said over here. And so the little picture that I had where x equals 2 for those positive numbers is absolutely 100% true. The problem is everywhere where x was negative, this part is negative, but this is the exact opposite positive value of that. So the region from -1 up until the number 0 actually cancels out, and there's nothing there. So we really are only looking for the integral from 0 to 3 of this problem. And if you actually test this on Desmos, you'll find that that's actually true. We're only looking for this portion, so we could say that we do have a base still from 0 to 3. So this area is not 8, but it's actually 6. So instead of saying that the answer is 8 times 4.8, it's actually 6 times 4.8. And so if that seems a little confusing to you, I'm super sorry. That turned out to be a little bit of a sticky little problem. I was trying to emphasize the idea that you want to simplify things first, but it got a little complicated. So we'll go ahead and leave that. Now, I did put in a substitute question that I think is more in line with what I might do on the test. And that's the idea is that if you had this simple little line like 3x plus 2, and we're trying to find out from 2, let's say, to b. Well, that's not a big deal. At 2, 3 times 2 is 6 plus 2 is 8. So this is the coordinate 2, 8. This coordinate over here, it'd be 3b plus 2. And so if I wanted to find the area of the shape under the curve, that area accumulation, I'm looking for the area of that trapezoid, which is base 1, 8, plus base 2, 3b plus 2, divided by 2, times the thickness, which is b minus 2. Now, that may seem a little bit obnoxious, but I've got 3b plus, say, 10 over 2 times b minus 2. And literally, there's nothing more that I can do with that problem, right? Because I don't know what b is. But again, if you follow the math, but there's a little sneaky thing here. If you multiply this through, you'd get a b squared. It's kind of a quadratic, but I think we know from recent times in the class, the antiderivative of this would be 3/2 x squared plus 2x. So if we plug in that b, we would in fact get that 3b squared over 2. You can kind of see the remnant of it. Okay, trying to finish up the first page, and then I'm going to go home because I'm going to finish this up at another time. So we talked about this. I know the journey went from 2 to 9, but I know about the cost it took me to go from 2 to 5. So this problem right here is really just saying, hey, what about that portion in the middle? So the 2 to 9, take away 2 to 5 is just the simple expression from 5 to 9. If we remove this portion of the journey, then the only portion of the journey left is the portion from 5 to 9 of f of x. And that's quite literally all I wanted to do. Now, for 5b, it's a little harder question. Is we have this idea from 3 to 7 and 3 to 9. Well, that's a little bit of a weird spot, but if we could rewrite this as an integral from 3 to 9. And because this one is written in reverse form, it shouldn't go from 7 to 3, it should go from 3 to 7. So what I'm going to do is I'm going to fix that, because we also know that if you reverse your bounds, that just allows you to change it to a subtraction. And that brings us back to this question. If I went from 3 to 9 and then 3 to 7, then the only portion that would be left as I remove this portion of our journey is the portion from 7 to 9. Hopefully that makes sense. Pretty good. Okay, now, next one down, again, pretty simple little idea, because I'm giving you some foreknowledge that I don't even know what the equation. I just happen to know that the area accumulation is 5 and that this one happens to be 12. So we're just going to play the game here, and we're going to break it into pieces. The integral from 0 to 5 of f of x dx plus 4 integrals of g of x dx. Sorry about the penmanship there. 4 of g of x's, also from 0 to 5. See, because a sum can be broken as two separate integrals, and constants can be pulled in front. But we already know that the integral from 0 to 5 is, well, it's 5. It says so right here. So I got that portion. Plus, keep in mind that's just a constant, that 4. So I'm ignoring it for a minute. But it's being multiplied by the answer of g, which we already know to be 12. So I think that's a pretty straightforward little guy. Then we got 5 plus 48, which is a total of 53. And last but not least, we've got this guy over here for number 6. Messed up question. Definitely want to reorder that because that's terrible. So we're going to go from 0 to 5 on both of these things. So the portion from 0 to 5 is going to be negative 3f of x dx's. And I'm going to actually switch this around because I'm factoring, which makes it negative. That makes it double. Good. Double negative. And again, also from 0 to 5. So I have negative 3f's, but f was known to be 5. And I've got 5 of these g's, which I knew to be 12, and it looks to me like I've got a negative 15 combined up with a positive 60, which is going to give me 45. And number 7, the last one for our video. I'm hoping this works because I've been told that my hard drive is getting full. But nice, easy little problem, because MRAM off of data is one of my favorites, because I'm going to find a data set that goes from here to here. So the middle, this is a data set that's 0.8 units wide, 0.8 units wide, and the middle would be 32.4 plus. Now keep in mind, when I find the middles, I'm going from here to here. So that point almost looks like it gets doubled up, but it's not. It's really just like breaking it up in chunks. And so again, I have a new unit that is 0.8 wide, but it's 25.6. And just be careful there because sometimes they're not even subintervals. The next one looks like it is in fact 0.8 by 20.1. And then a 0, I'm guessing again, so I guess probably true again. The last one is in fact 0.8 times 13.8. And very, very simple arithmetic is going to lead me to the number 73.52 as my total answer. Now, we like to do things to 3 decimal places, but in this case, that's all we were provided is exactly 2 decimal places. So I think we were able to get away with it in that particular circumstance. So I think we're done with that for now, and that is the page 1 of our unit review, which is, like I said, a pretty short unit review. And I'll see you back in class. Bye-bye.